Hello and welcome to another video where we're going to do some statistics. Today we're going to talk about Superman's strength test. Look at him punching through that punching bag. Super awesome. I just realized that my brother and one of my best friends are very large Superman fans, and I haven't done a Superman themed video yet, and so I'm going to fix that today. Alright, so what's the problem set up? Is Superman's average punch force stronger than most of his rogues? Can he land blows with the best of them? So I have this population mean force of 7 for his rogues gallery. I want to explain that. So I have some data that I pulled on the strength, speed, intelligence of a bunch of his villains, and so these are on a scale from where 2 is sort of like human, 8 is more like Kryptonian, dark side at a god level, and then you've got Doomsday over here at 10, right? So just a good spread of his rogues here, with some context for the strength. Okay, so oh, yeah, and we don't know what the standard deviation is, right? So maybe we just have some sort of a sample standard deviation. Oh, let's do this. Let's do population standard deviation, and we're just going to make it unknown. Like, I don't know what it is, right? There's a lot of variability in the rogue, so I don't know what it is. So a simple random sample, Superman's punch force measured over multiple instances. That's in the Excel spreadsheet. So let's go ahead and go over to Excel and look at his rogues and then see how we would do a test, right? So here are his rogues. The average for the strength of this sampling of rogues is 6.8. So what I did was I said, all right, let's have a hypothesized mean of 7. Let's sort of round up, right? And let's see, is Superman capable of punching more than that? Now, I do not know what the population standard deviation is. When you don't know what the population standard deviation is, you need to use your T distribution and calculate a t-test statistic. Now, our assumptions for using this test are if n is greater than 30 or the population is normal, then this is perfectly okay, right? Now, the sample size is not over 30. My sample size is 20. And so what I need to look at is, because it's less than 30, because n is less than 30, is the sample normal, right? So if the sample is normal, we can say that the population, or at least the sampling distribution, is going to be normal. And so we tend to look at these things, right? So what I'm going to do is I'm going to grab the data, come down, and in this space right here, we are going to insert a histogram to see what it looks like. Now that histogram is looking a little bit right skewed. There are 20 there, right? So let's see, this is our sample data. Let's see, we're going to format the chart title, and we're going to say Superman strength sample, right? For our chart title. Okay, and then there it is. So it's looking a little left skewed. I don't know. Maybe this isn't so great. All right. The other thing that we could do is we can grab the data. And we can insert not a histogram, but a box and whisker plot to see if we have any outliers. Now, we don't have any outliers. Let me grab the actual chart. Let's pull it down over here and make it a little smaller. We're setting this up as a template so that we can put other data in. There's no outliers, but again, it looks like there is some skewness there. Now, we could test this for skewness. We could do a QQ plot or a Shapiro-Wilks test, right? But let's for the moment just say, hey, look, this data is going to be normal enough. It's not. It's not normal enough. But let's just say that it does. Let's say that it meets the normal distribution. Now, if you have summary data, that stuff will all be given. Now, here we have data, and I want to show you how to do the test with data, because then this is filled in and all the rest of it is the same. So if you have data, or if it's summarized, it's here. Now, if you do have data, you want to take the average of that data in column A, and if I do the A colon A, remember that's our cheat code for getting all of the data no matter how much there is, and I hit enter, and I see that the sample mean is 8. Now this is good, right? It's higher than 7, but is it statistically significant? Because we know samples vary. And so maybe it's just 8 at random, and it's not really that large. So what I need is the standard deviation of my samples. So that's going to be S. And again, I want it for the whole column of A, and that's going to give me the 1 point. Now that is way too many decimal points. So let me make that 2 decimal points. That makes a lot more sense. And then the sample size, we are going to count our data in column A, and it's only going to count things that are numbers in column A, and we can see that it is 20. So now, if you had summary data, it would just tell you the sample mean, the sample standard deviation, and the sample size. You would fill that in. The hypothesized mean would be your null hypothesized mean, and so that would go there. And so we're going to look at this. Okay, now the standard error is 0.348. That comes from taking the, like this. That comes from taking the sample standard deviation and dividing it by the square root of 20. So if I have something slightly less than 2 and I'm dividing it by the square root of 20, I'm going to get about 0.348 as my standard error, the amount of variability that I would see in the sampling distribution. Now, my test statistic is just like what we did for sigma known, right? It's still the sample mean minus the hypothesized mean divided by the standard error. And so those 3 things are still true, but it's going to be a t-test statistic because we are using the t-distribution. Now, if you watch my video on Batman solving crimes for sigma known, you will know that I actually had to do the complement rule, and then I had to use an if-then statement to get my not equal to. The nice thing about the t-distribution is t-dist is my left hand, x is less than, for my alternative hypothesis. T-dist dot RT stands for right tail. That's my greater than if my alternative hypothesis is greater than. And my t dot dist for 2t is there for my not equal to, and I don't need an if statement. Now, I want to pause here for just a second. You will get an error message if this t value is not positive. So what I had to do was I actually had to put the absolute value function in to force my test statistic to be positive, all right, so that I could use this function. If your test statistic is negative, then you get an error message in here. So that fixes that, all right? And so there we go. And now we can see that out to 4 decimal places, he is definitely stronger than at the 5% level of significance. Even at the 1% level of significance, Superman is stronger than his rogues, right? So that not unexpected, right? Now, does this mean that he is stronger than all of his rogues? No, it doesn't. His sample mean for them is 8. Their average is 7. Now, there are a few rogues. Zod is an 8. Metallo is an 8. But remember, Doomsday is a 10 and Darkseid is a 9. He goes toe-to-toe with these guys, but it is his fighting ability, right, his speed and intelligence that allows him to defeat some of these opponents, sometimes with the help of Batman. Sorry, I couldn't help but throw that in. All right, so now we're back to our sheet. And now we're ready for our interpretation. So at the 5% level of significance, we reject that the mean punching strength of Superman is equal to 7. We have evidence that the mean punching strength of Superman is greater than 7. That p-value is the 0049. So let's go ahead and throw that in. 0049. All right. If you learned something about Excel, the t-distribution, and Superman, that makes me happy.